Bismillahirrahmanirrahim. Respected sir, first of all, I'm very thankful to all of you that you give us your precious time to present our presentation in front of you people. Let me introduce myself. My name is Asad Iqbal. My group member is Muhammad Ateef and Hamad Raza. Let's start with the introduction. Polygraph foundation are used in high-rise building. They are also used in the area where the bearing capacity of the soil is less in order to prevent excessive settlement. They are also used in the places where soil its shallow depth is highly compressible and water table is high. As the number of high-rise buildings and the world is increasing, in order to have high floor to area ratio, these buildings are involved the storage capacity or parking spaces in one or several basements. The lateral load carrying capacity of the basement wall is often ignored. Pile-drop foundation. Pile-drop foundation is constructed by combining both the pile and drop foundation, which as a result shape structural loading. The behavior of the pile-drop foundation under lateral loading is combined loading is completely different from that of pile or pile group. The lateral load in the pile raft is partially shared by the pile and partially by the raft. Although these research related to the pile raft foundation under combined loading is rather limited, the available literature on the research carried out on the pile raft system considering lateral loading or combined loading are summarized. Problem statement. Traditionally, in pile raft foundation, the contribution of raft resist load is ignored due to the fact that its analysis is quite complicated soil structure and direction. Hence, the simplification may lead to an uneconomical design. The response of basement wall under lateral loading is not understood fully because it is studied analytically only. There is negligible study related to the pile arranged in the direction parallel and perpendicular to the pile lateral load and their effect on the load contribution of pile raft with basement wall. Objective. So to understand the behavior of the pile arrangement in parallel and perpendicular to the application of the lateral load and pile raft foundation with basement wall. Comparison of pile arrangement and pile raft foundation with basement wall and pile raft with same arrangement under lateral loading and sandy soil. Now I will like to my group member Muhammad Ateef to proceed for the presentation.
There were two types of soil tests conducted on the sample. The first one was the sieve analysis and the second one was the specific gravity test. In the sieve analysis test, we made the gradation curve in which we found the coefficient of curvature and coefficient of uniformity. As the coefficient of uniformity was less than 4 and coefficient of curvature was outside the range of 1 to 4, therefore it is a poorly graded soil. The specific gravity test was performed using the picrometer, and the specific gravity was found out to be 2.63. Modeling and instrumentation. For the modeling, we made for the modeling of the piles, we used the GI fabricated piles that were having the length of 1 feet and the outside diameter of 0.75 inch and inside diameter of the 0.5 inches. For the basement walls, we used the aluminum plates of the height 6 inches and the length of 12 inches. And the thickness of the basement wall was 0.4 inches. For the raft, we used a square, one feet square aluminum plate, and there were holes were dug into it at the distance of 2.5 inches. There were total of 25 holes dug into it. And for the strain gauges, in our test there was only 4 strain gauges were used. In total, there were 6 strain gauges, but 2 was used for the vertical load and 4 were used for the lateral load. Transducers, in order to quantify the lateral displacement, we used the transducer that had the maximum displacement of the 25 mm and the least count of 0.001 mm. For data logger, in order to quantify all the values that came from the transducer or piles and the load cell, we use the data logger. Lateral load cell is used to quantify the lateral load applied horizontally to the basement wall. Procedures. We arranged the configuration as per required. Then we excavated the soil from the walls. we set the assembly and coincide with the rod coming from the lateral load cell with the mark on the basement wall, and then we poured the land by using the method of the sand draining technique. Then we applied the static load of 400 kg. We set the transducer in such a way that the lateral displacement due to lateral load is recorded. Connected the assembly and lateral load cables to the data logger and note down the channel numbers. We connected the data logger to the laptop and applied the lateral load until the lateral load ceases to increase or it becomes constant. At the end, stop the test and save the data. Now I will invite Mr. Ahmed Reza to come and present.
Thank you, Muhammad Atif. As we can see, this is the isolated basement testing. The transducers are connected opposite to the load applied. This is the 3 piles parallel configuration in which we will apply the load opposite to the connection of the transducers. From the figure we can see that we will connect the transducers to this side and we will apply the load from that side. This is the 3 piles perpendicular configuration which is clearly shown. This is the piles are placed perpendicular to the applied load. Okay, so these are the results in which we compare the displacement of the different pile configurations at a constant load. The constant load is, we compare the result at a constant load of 2000 newtons. We can see that as the number of piles increase down the table, the displacement decreases. From the graph, we have done another comparison, which is the start of the initial displacement of each configuration. So for the basement wall, without the piles, the initial displacement starts at a load of 176.5 newtons, and for the 3 piles perpendicular to the load, it starts at 312 newtons. For the 3 piles parallel to the load, the initial displacement starts at 504 newtons, and for the 6 piles perpendicular to the load, the initial displacement starts at 646 newtons. Again, for the 6 piles parallel to the load, the initial displacement starts at a load of 790 newtons. From this whole discussion, we can say that the as we increase the number of piles, the displacement decreases. And the other result which we can conclude from this is that the parallel piles, they offer more resistance as compared to the perpendicular ones. This is the graph of the 3 piles parallel configuration to the lateral load. So we can see that the front piles, they offer more resistance as compared to the rear ones. Here in the 6 piles parallel configuration, we can see that the front piles offer more resistance as compared to the rear one. This is because the vertical raft contribution, which increases the stiffness of the soil in front of the piles. This is the 3 piles perpendicular to the lateral load. We can see that the corner piles, they offer more resistance as compared to the middle one. This is because of the interaction of the corner piles on the middle pile. In the 6 piles perpendicular, this is also the same case, but in the 6 piles perpendicular case, the leading piles, it means that the front piles to the load, it offers more resistance as compared to the rear ones. This whole discussion is here. Now the conclusions of the tests and our whole research work is that the maximum displacement, it decreases as the number of the piles are increased. For example, in the isolated basement, the displacement was more, and similarly for the 6 piles parallel, it was the least one. The maximum displacement in the parallel configuration is less as compared to the perpendicular configuration in 3 piles as well as in 6 piles. In case of the parallel configuration, the front piles are taking more load in comparison with the rear pile because of the vertical raft contribution, which increases the stiffness of the soil in front of the piles. In case of the perpendicular configuration, the corner piles are resisting more load, which is due to the interaction of the corner piles on the middle ones. That's all from our side.
Okay, so go back to the previous slide.